become evident that the recharge to groundwater would get significantly increased, even more than what the recharge which we are aiming at by means of the engineering interventions and the works as such. Now let us see what these are. Firstly, we have to mention about the cover crops. Cover crop is nothing but a vegetative growth on the rain-fed land to keep the soil covered. It has two purposes. One is to prevent the soil moisture evaporation that occurs mostly during the dry spells and the summer periods. It will not prevent totally, but then the evaporation gets reduced. Soil moisture evaporation gets reduced. And the second purpose is the green matter or even the dried up matter related to the cover crop would serve as green manure, organic manure to the rain-fed lands. When such green manure or mulch is trampled into the soil structure improves, and this is the other benefit out of the green manure. Now let us see why we need these cover crops at all and what is the significant role it plays in the total water balance. This word total water balance means that the rainfall occurring in a particular region or a watershed, how it is stored in various domains or how it is made available in various zones. Now let us say if 100 units is the rainfall at a particular place, and for example we take a red soil area in the drought prone regions, then the distribution of that rainfall would approximately be like this. About 10 to 15% of the rainfall would go for recharging water table. About 20 to 25% of the rainfall would go as runoff, surface runoff. And the balance, nearly 60 to 65%, is held in soil moisture zone, in soil, in the weathered zone, which is above the water table. This is held under capillary suspension right up to field capacity and less than the field capacity. That is the capacity up to which it can store water under capillary suspension. So this water which is stored in the soil is used by the crops in the root zone as well as by the trees with its roots spreading right up to water table in some cases. And in addition to this, the soil moisture is getting depleted every summer due to evaporation, soil moisture evaporation. Even though we say about 60% of it is held under capillary suspension in the soil, most of it is lost when the rainy season, when the summer season ends. Now, if we can reduce the soil moisture evaporation to some extent, what does it mean? To that extent, the groundwater recharge would get increased. If supposing the amount of soil moisture evaporation is as much as 60%, of course this evaporation also takes place immediately after the rains, which means again the evaporation from the soil only and the soil top layers. If supposing this evaporation is reduced to say 30%, then when the next rains occur, it can be brought to field capacity with much less percolation, and any further percolation would go for recharging the water table. If supposing there is soil already having some moisture, and when the rains occur, a considerable quantity of infiltrated water would go to recharge the water table. If the soil is bone dry or is at a wilt point, then it has to be brought to the field capacity before it can gravitate down below to recharge the water table. So therefore, any prevention of soil moisture is of great significance in the total water balance. It is of great significance to improve the recharge to the water table. Is it possible? How is it possible to do this? Is it occurring in nature? Let us examine this. In the nature we have a good dense forest, supposing there is a good dense forest, which means there is a good vegetative cover over the land, over the ground, and at times we don't even see the sunlight falling on the ground. Such is the denseness of the forest. And the forest floor will be having lot of grasses, creepers, small scrub growth and things like that, dead leaves. All these things will constitute the forest floor. In such a situation, when rainfall occurs, most of it would be going to recharge the water table. So therefore, in the forest areas, water table would be at a fairly shallow depth. In spite of the trees taking away so much of water, still there will be a sufficient amount of balance in order to increase the recharge. On account of this favorable groundwater condition in a dense forest, the streams flowing in the forest will have the seepage flow from the groundwater zone. That is also observed during the summer periods. Usually when there is a rain, the runoff occurs, and this runoff would cease after a few days. But in the case of a forest stream, even after the stopping of rains, we find some base flows. We find some spring flows much later than the rains stopping. For example, the rainy season is over by October. We find the base flows or spring flows in the stream coming from very dense forest, occurring even in the month of March or even in the month of April, or also in the month of May in the case of some good streams. So what is this water that flows as spring flow? This is nothing but groundwater. Groundwater appearing as surface water in the valleys. So that is the spring, or that is the base flow. So these base flows are occurring in a well-wooded forest where there is a good growth of trees and where the soil is having some cover which prevents the evaporation of the soil moisture, and which also facilitates the direct solar radiation not occurring onto the ground. So when direct solar radiation is not there, and when the soil moisture evaporation is reduced, there is scope for getting the spring flows. There is scope for more of recharge to the groundwater. Now, can this be imitated in the rain-fed lands? Can the natural forest be imitated? Those conditions can be imitated as far as soil profile is concerned. Now, let us consider like this. The rainy season ends by, say, middle of October. Then when there is some still moisture in the soil, we dibble certain green manure seeds, mostly the bean variety of seeds, either lab, anumulu, or velvet bean, or any bean variety. there would be enough moisture in the soil to facilitate germination, and this dibbling of seed could be just after the harvest of the Kharif crop or even before the harvest of the Kharif crop. When the crop is harvested, there would be already some germinated seed which grows up, and it takes the residual moisture in the soil and grows up to February. We don't expect any yields from this grain manure crop. We just dibble the seed and don't expect any yield. But then whatever crop that grows during the Rabi period up to end of February has got to be protected. It has got to be prevented from grazing. And if the whole village takes up this activity, then they will prevent the cattle from eating or grazing there, and this will be a cooperative effort, just as what they do in the Kharif period, they have to extend it for the Rabi period. And when that happens, the growth up to February would be there. And later on, the crop starts withering away, because the residual moisture may take care of 1 or 1.5 months, and the subsequent winter and dew and things like that can take care of another 1 to 1.5 months. So therefore up to February end it's already green. Many cases it can be green. Then it starts drying up from the month of March onwards or from the end of February. And when it dries up, also it has to be on the ground in a dried shape, a sort of mulch on the ground. And in the month of May, early rains may come up in some areas by middle or end of May or the first week of June. When it rains, then it will be plowed and trampled into the soil, and it gets mixed up as green manure into the soil. Such green manure would improve the soil structure, and when this is repeated for 2 or 3 years in the same manner, at the end of every Kharif period we sow a bean variety of seed, and it comes up every year like that. The second year growth would be much better than the first year growth. That's because in the first year we already trample some green manure, so there is improvement in the soil structure to hold more moisture. Also there is some additional fertility through organic manuring. So the second year growth will be much better. In the third year growth, it will be very good. That means the whole ground will be covered with this cover crop. Now one point arises here. In what way the farmer is interested in this when he doesn't get any yield out of the crop? What he has to do is only dibble the seed and forget about the yields. The yield is in the shape of additional manure for the farmer. For example, if we evaluate the amount of increase in fertility of the soil, it would be about rupees 2,500 per hectare after the third year. Because in the first 2 years it will be less than that. And this is the benefit to the farmer. In addition to this, there is another benefit to the farmer. By virtue of improving the soil structure, it has got more water holding capacity. It can hold more moisture. And during the rainy period or the Kharif season, we usually get drought spells. In some years it could be as small as 15 days, but in some other years it could be 20 days, 25 days or even 30 days drought spell. When such drought spells occur, the additional moisture stored in the root zone would be of great asset. The crops do not wither away even in